Good morning, Jim. I got your data. I'm going to do a quick look over. Now, I reread your email, and it says that she wants the test scores to be the IVs and the college achievement, which is a 0, 1, 2, which I would consider categorical variable, be DB. If she wants to do that, that is a discriminant function analysis test. It's like the backwards of a MANOVA. It takes the test scores, the IVs, and it tries to predict whether that person will end up in the 0 category, 1 category, 2 category. Again, that's a discriminant function analysis. Now, I looked at the output sheet. The way you did it is perfect. That is the way to run the ANOVA. And I'm going to do it again, and I'll explain as I go. Hold on. The first thing I do is I check for the correlations between the DVs. They're supposed to be correlated between 0.3 and 0.8. So let me go to correlate by variate. And here they are. And the only thing I need here is to check. And I realize this is dummy data. This is not real data. But number one rule about running a MANOVA is, let me get this on the screen for you, is you can't have any negative correlations unless they're all negatively correlated or all positive. But normally you want a positive correlation between all of these, between 0.3 and 0.8. So this data, you got serious problems. And again, I know it's fake. This number is way too high and it's negative. This number is way too high and it's positive. You don't want it to be greater than 0.8, and you don't want it to be less than 0.3, and you got a bunch of low ones too. So that just means right off the bat, if this was the real data, you would not run a MANOVA. You would probably run 4 separate ANOVAs. But on to the MANOVA. I would go to Analyze, General Linear Model, Multivariato. There's your DVs, the test scores, and there's your grouping variable, your IV, fixed factor. And I only go to options, and I get descriptives, effect size, power, and the homogeneity tests. Click OK, click OK. So here's the output. These are your 3 groups. And I look at the means right off the bat. So here's the CASP test. These are all really close. I doubt that there's going to be any significant difference here. Go to the PCST. Big difference here. You got a high of 0.75 and a low of 0.25. I guarantee you there's a significant difference there. SAT, same thing. You got a 0.24 and a 0.74. Significant difference. ACT, significant difference. 0.24, 0.72. And the multivariate test tells you that your overall MANOVA is significant, which just means that there's a significant difference between 2 groups in there somewhere. It doesn't tell you where. And this Levine's test says that you violated the assumption of homogeneity of variance on one of the tests. No big deal. Keep going. And here's the money box. So you can either use the corrected model or the college persistence model. They'll be exactly the same. And it agrees. There's a significant difference somewhere between group 0, 1, and 2 in the PSAT and the SAT and the ACT, but not the CASPP. Now, you could run those post hoc tests if you want to, but you really don't have to, because you can, now that you know where the differences are, you can simply go up to the group means, the descriptive statistics. So there was no difference here, but there was a difference in the PSAT. Man, why am I struggling? Right, and you can see where the difference is. You got a high. The 2 group is high. The 0 group is low. And the SAT, it's the 2 group that's low and the 0 group that's high. And the ACT, the 2 is high and the 0 is low. So, but again, the way you did it is correct. And you cannot use those IVs, the test scores. Those are the DVs in a MANOVA. Again, I'll say that again. You cannot switch the DVs, the test scores, those continuous scores. You cannot make them into IVs and run any kind of ANOVA. So I hope that helps. All right. Talk to you soon. Out.